Hello everyone, I am Dr. Shriram Raut, working as Assistant Professor at Department of Computer Science, School of Computer and Sciences, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. My roll number is 13, and as a part of micro teaching in refresher course, I am going to present a topic that is Introduction to Machine Learning. So if you consider about to have this particular machine learning, so it is one of the subfield of artificial intelligence that it has import various smart applications. So we'll be having deep learning, machine learning and artificial intelligence. Artificial intelligence mainly talks about how to make machine do things which at the moment people do better. So we are just taking a step ahead of this particular artificial intelligence to make machine learn things by itself. So for this particular machine learning is as blooming as one of the, you can say, recent trends in information technology and computer science. It deals with the construction and study of system that can learn from data. So completely automated system where human intervention is much less, will be more focusing on minimizing the human intervention and going to deal a maximum freedom where the machine will think, act and behave like the human beings over there. It is about to aim just to have the machine to predict something over there. So we'll be able to give the data, we'll be recording the data, and by observing the pattern of the data representation we will be able to make some sort of prediction. For example, weather forecasting is a kind of thing where we can give 5 years of data that what could be the tropical region we'll be having in hand, and how the particular machine will be analyzing that particular data by means of having this machine learning algorithms and data science in association. It will be able to predict in what month what sort of rainfall will be over there, and whether it will be in a smaller scale or say a major scale. It could be targeted to predict unknown things or events. So it is about to have again the pattern recognition in consideration, that we will be having a similarity matching. We'll be looking for more about the likelihood in consideration by means of having various algorithms that could be put forth as a learning mechanism for the machine over there. So you see, as an overall, machine learning is a subfield of artificial intelligence, and that has import various smart applications. So smart applications means just like we'll be having a progression of data, information, knowledge, and about to have the intelligence in consideration. So considering more about the data in hand, that is the basic fundamental element in a progression of the intelligence over there. So data is basically collection of disconnected facts we'll be able to have. Once we'll be having organization and analysis of this particular data as a disconnected fact, we could be able to lead up with the information, and this information, if we organize it in a proper way, we'll be having a proper you can say a mechanism for the interpretation and the mechanism for evaluation of the information. We certainly have the knowledge out of it. And if you consider knowledge in hand, that applying the knowledge in the right context and looking for some sort of you can say thing where we'll be looking for generating something new from the existing one, the particular term for that, it is a inference. If we will be able to generate something new from the existing data, we call it as an inference, and that inference will lead us to have the intelligence over there. So we usually follow a particular you can say stream of vehicles where they are regularly passing through the gateways of toll. So we can have the smart application over there just to look for the particular vehicle belongs to what category, whether it is a two-wheeler, whether it is a four-wheeler, whether it is a six-wheeler, or whether it is a long type of vehicle. So we can just make a light motor vehicle and you can say heavy motor vehicle classification. So basically making a passing through that particular toll gateways, we can have the cameras to be installed, and at present the cameras are about to scan the RFID over there. But beside of having the RFID, we can introduce a smart application where the number plates are to be scanned, and after scanning the number plate we will be able to decode that whether this is belonging to the state of Maharashtra, whether the vehicle is belonging to the state of you can say Madhya Pradesh or Karnataka. So we'll be having a simple encoding type of scheme over there, where we analyze that about to have some 16 consonant from A to Z and digit 0 to 9. So we could be make a combination of that. So we'll be having disconnected fact in terms of this particular A to Z as a consonants and alphabets basically, and 0 to 9 as digit over there. So if we make a proper organization and analysis of this particular consonants, we could be combine the two different literals or alphabets over there. For example, MH, MP, KA, then TN, then GA, then we can have this particular RJ. So all these particular two letters will be having an extended meaning over there. So MH will stands for state of Maharashtra, MP will stands for state of Madhya Pradesh, GA will stands for Goa, then KA stands for Karnataka, RJ stands for Rajasthan. So this is an encoding scheme where the first two letters will be pointed as a part of having organized analysis, will be having information, and we certainly have the knowledge that the first particular two letters will be able to point up for the state code. Then we'll be having a 2-digit combination. So for example, if it is a MH13, that 13 will point for the particular city in a state of Maharashtra, which is Sholapur. So this particular thing we can encode with every state, and we'll be having a sort of information knowledge related to that. Then we'll be having a type of again the sequence with the help of characters, and then finally the digits over there. So by having this particular pattern of representation, we could be able to have the smart application, where smart application will be able to tell to the RTO system whether this particular vehicle is having valid PUC, whether this vehicle is having valid RC, whether this is an age of the renewal stage of that particular transport vehicle or say non-transport vehicle, or any additional information. Sometimes the particular accident may happen onto the roadways and highways, so we could be able to trace out easily by mapping this particular concern with our smart application, by having data integration of the data information knowledge, and finally the intelligent system, where that will be going to give a sort of query based answer as an expert system, that this particular vehicle is owned by whom, whether it is a first customer or whether it is a resale kind of second customer in an you can say RTO allotment for the case of ownership and vehicle registrations over there. So basically this particular machine learning has evolved in the year of 1959, and two different definitions come up. One is proposed by the Samuel in 1959, another definition as a context of meaning of representation of machine learning that has been given by Tom Mitchell in 1997. So Samuel has given a simple line of definition for machine learning as an evolving you can say trend in computer science, that it has declared machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. So it is again pointing for the automation in representation. We'll be having a more focus on minimizing the human intervention. The system should act, behave and think like the human beings, and will be having a completion of the task or task doing sort of activity will be performed as like the human being. Later on, a sort of refinement will be made by Tom Mitchell in 1997, and he has proposed that machine learning is basically a computer program is said to learn from the experience E with respect to some class of task T and performance measure P, if its performance at task in T as measured by P improves with the experience E. So we will be having a type of mechanism where every time we will be having an evaluation system. Just like if you consider that if you will be able to make you can say student who is pursuing his education in standard 2, and you are going to make him learn or her learn the table of 2. So we'll be having a table of 2, 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8. So these 4 samples we have given to that particular student, and what he will do, that he will be able to analyze the pattern over there. So we are going to make a training a kind of thing. You are training that particular student that how to write a table of 2. So you have given a sort of learning algorithm to it, okay, and you have given some tasks that I have given you only 4 first you can say steps of the table. You need to generate the later on steps. So what sort of formula you are going to set up over there? So you are going to set the formula that you have multiplied 1 with 2, you have multiplied 2 with the 2, you have multiplied 2 with the 3, you have multiplied 2 with the 4 over there, and likewise you have generated the result of multiplication as a table of 2. Now this is one thing that we'll be having, Now another strategy that could be over there as a class of task you talk about, that we can just make the summation of the same digit on the occurring result over there. Just like you can say it is a 2 plus 2 it is a 4, 2 plus 4 it is a 6, then 6 plus 2 it is a 8, and likewise we can have addition of the same constant digit in every resulting state of that particular, you can say, addition series. Okay, so basically these two class of tasks we can have, and the student is about to have the experience that how the teacher has given a sort of table. Either one strategy as a logic of representation is there, where we talk more in concern of having the multiplication as a basic arithmetic operation in order to generate the table of 2, and another task of class is there where it majorly talks about how you will be generating the result and adding up the type of number whose particular table you want to generate over there. So experience kind of thing is given to two different batches, as batch 1 and batch 2, and they are about to have the performance. So you'll be measuring a performance whether the particular candidate is about to, as a student, he is about to generate what will be the state of 2 5s are. So at what particular position 5, what particular digit you will be expecting over there. So you'll be making a performance measure whether the task you have given is worked out in a right manner, whether he is going to perform the arithmetic addition just to generate 8 plus 2 as a 10, or whether he is going to make a class of task where we have given a particular task with multiplication of the next state, just like having enumeration of the series as a count to be incremented by 1 as a 1 2 3 4 to be multiplied with the digit 2 over there. So the next step is basically 5 multiplied with 2 is a 10. So we'll be having a performance measure whether he is generating 5 into 2 as a 10, whether he is generating again 5 into 2 as a 8, or whether he is having a question mark that what will be the state of multiplication of 5 into 2. Just like similar the case, we will be having as an of the 8 plus 2, whether he is generating 8 plus 2 as a 10, 12, or say a 6. So we will be having a feedback system. So basically it is a performance measure, and we will be just about to uplift the performance of the system by giving some feedback over there. So our main task is to have a performance at particular task T that to be measured by some performance measure parameters, and we have to ultimately improve with the experience E. So experiences could be given to that particular machine related thing, and we'll be about to put some algorithm, and on tackling that algorithm, machine will be having an automation in its process of thinking and generating the results over there. So if you are able to make that particular student to just generate the table of 2, automatically you don't have to give the strategy, you have to just tell that this is the particular arithmetic addition and multiplication you can go for, and you can simply generate a table of any number. Either you say it is a number 20, so he will be following the same strategy, enumerating a count by 1 as a 1 2 3 4, 1 into 20, 2 into 20, 3 into 20, 4 into 20, and likewise he will be generating. Either you say that just like having the addition of the single constant term 20 with every generating result over there. So just like 20 plus 20 it is 40, 40 plus 20 it is 60, 60 plus 20 it is 80. So this is where I need to make a cross check whether he is working in the right way or no, and you give the feedback to have the performance metric in consideration. You will be having a mark awarding scheme over there. You will be going to give some rewards. Usually the teachers follow this particular strategy to train their students. So in that perspective, this particular Tom Mitchell definition comes into consideration. So these are common terminologies we can have in machine learning as a vector space, sample, feature space, and label data. So all this is to be used in order to have the data representation and related consideration. Now we'll see the basic aspect of having the consideration for the case of the particular one that we can have in representation. So that there are basically three types of machine learning. One is supervised, another one is unsupervised, and third one is a reinforcement learning. So supervised learning is where, just like it is a tutor based learning, we can say it is a teacher based learning. Someone should be over there to guide us in a right way to look for the consideration of feature set and all. So if weight is a feature and currency is a label, we'll be having a weight. If we consider it is a 3 grams of the weight of that particular coin, we can say it is a rupee. If it is a 7 grams, we can say it is a euro, and if it is a 4 gram, we can say it will be the pound as in currency over there. So the type of representation will be having with difference of the weights over there. Based on that, we have given some supervised algorithm to the machine to check whether this particular coin belongs to the class of euro, or say a pound, or say a rupee over there. So if you put the input for checking whether this is a rupee, whether it is euro, or whether it is a pound over there. So if the weight matches as a 3 gram, we can say it is a 1 rupee coin over there. This is basically a labeled data we'll be having in supervised learning, and we'll be able to make the prediction based on that using the machine learning strategy as to go with the supervised learning. So supervised learning could be guaranteed by means of having various algorithms where we practice an algorithm of the SVM, that is support vector machine. We talk about the sort of algorithm where we will be able to make some sort of margin and the boundaries of the decision making. So various paradigms are there as a part of supervised learning to make machine learn. Decision making trees are also there. Unsupervised learning, here the complete different case is there. Just like the supervised learning will be having the labeled data, in unsupervised learning will be having the unlabeled data. So you can say a learning made by Dronacharya to the Arjuna is a supervised kind of thing, and the learning made by Eklavya by just making the statue of his guru Dronacharya, it is to be considered as an unsupervised learning. So we'll be having unlabeled data, we'll be more looking for the maximum likelihood, we'll be looking for the similarity matching, and we are just rounding up the groups. We can say it is basically the sort of clusters in a form of representation, and we will be able to deal with that particular data where the labeling is not there, and we just have to simply observe the pattern of the representation, and we need to form the clusters over there. So see, a type of dog is there and a cat is there. Our system is about to make some sort of prediction over there whether it is a dog or cat. So if it is exactly identifying the dog itself as a dog, it is going in a right way. If it is misinterpreting the dog as a cat or cat as a dog, then there should be a sort of feedback that where to make some sort of correction in a recognition algorithm. So that would be given by the third strategy of our learning. We call it as an reinforcement learning. Just like as an example I have given, to make a learn student a table of 2, we need to give the feedback whether he is going and doing the things in a right way or no, or whether there should be need of correction. So this is all about the micro teaching topic that I have chosen, that is machine learning, and I suggest you to learn this particular subject. This particular subject is very interesting and very useful over there. Thank you very much.